Welcome back. The objectives of this video are to review angle of elevation and angle of depression, and we will also use right triangle trigonometry to solve a couple of application problems. Just to review, the angle of elevation is the angle at which we look out on the horizon, and it's our angle that's looking up. So if we're standing on a cliff or we're standing on the ground and we're looking up at some object, our angle of elevation is the angle looking up. Whereas our angle of depression is from our horizon looking down. Be careful. A lot of guys make the mistake of using the angle from looking down at the object to their toes as the angle of depression. That is not the angle of depression. The angle of depression is the angle formed by looking straight out at the horizon and then down to an object below. This is your angle of depression. As it turns out, our angle of depression and our angle of elevation are the same because our angle of elevation from the object to the observer is the same as our angle of depression from the observer to the object, because our horizons are parallel and these alternate interior angles are congruent. Solving some application problems, we see here that a biologist wants to know the width of a river in order to properly set his instruments for studying the pollutants in the water. From a particular point A, the biologist walks downstream 70 feet and sights a point C. From this sighting, he knows that that is 54 degrees. That is a very talented biologist that can eyeball angles. But he does, he eyeballs that angle at 54 degrees. Now he knows he walked 70, and we want to find the width of the river. So from our reference angle here, we want to find the opposite, and the biologist has the adjacent. So we need a trig function that involves opposite and adjacent, and that is tangent. Tangent is opposite over adjacent. So our reference angle is 54, so the tangent of 54 degrees is equal to the length of the opposite side, W, divided by 70. We want to solve for W, so we multiply both sides by 70. We get 70 times the tangent of 54. And the tangent of 54 is some value that's in our calculator, it's stored away, equals W. So this, I would say, is calculator ready form. We're ready to put that in our calculator. So we make sure our calculator is in degree mode. 70 tangent, put in your degrees of 54 degrees, and we get 96.35 as our answer. So we know our W is 96.35. So be careful, just make sure you've got your rounding correct as asked for. We'll do another sample problem here. A ramp 17.5 feet in length rises to a loading platform that's 3.5 feet off the ground. Find the angle theta that the ramp makes with the ground. So we actually do want to find an angle of elevation here. So this is going to be a little bit different. We want to find the angle. That's what we don't have. We are going to use our arcsine, cosine, or arctangent here. So let's figure out what trig function we want. Well, 3.5, we have the opposite. We assume that that forms a right angle here, so the 17.5 is our hypotenuse. So we need a trig function that involves opposite and hypotenuse. And that is sine. So the sine of our angle theta equals the opposite 3.5 or 7/2 over 17.5 or 35/2. Simplifying our complex fraction, the sine of theta is equal to 7/35. We have our ratio, we have our fraction, we need the angle, so we're going to use the arc sine of 7/35 equals some particular value. So we make sure, we go back to our calculator, we make sure we're still in degree mode. So the arc sine, 7/35, gives us an angle of 11.54 degrees. So we know our angle of elevation is 11.54 degrees. That is the angle theta that we need to have for our ramp. And there's a couple of sample problems, a review of angle of depression and angle of elevation, and we'll get some more practice with this when I see you in class.